Hi guys, let's do a quick experiment. I have here a book, and from the book I've taken out one sheet of paper, right? The experiment is simple. If I drop the book and the paper from the same height, which one do you think will fall faster? Let's try it out. Okay, that was loud. So clearly the book fell first and the paper was just floating away, right? Now, maybe it's just the height that I was dropping it at. Now, what if I raise the height, right? The book still fell faster. Okay, there's one variation we can try where we can, try to make both the book and the paper fall simultaneously. Now, what if I place the book on top of the paper? I mean, the paper is still at the bottom. It should still float away while the book falls straight. Don't you think? What do you think will happen? Pause and rethink. Okay, now let's do the experiment. So I have the paper and the book is on top of the paper. Now 3, 2, 1, go. Okay. Quite intuitively, the book actually pushed the paper and both fell at the same time, right? Nothing unusual there. Let me flip the situation now. This is where it gets interesting. So I have the paper and I place it on top of the book, right? Now, if I were to ask you which one would fall faster, what will you say? Again, pause the video, think for a couple of seconds, and then have it in mind what you think. Now let's try it. So the book and the paper is on top of the book, and I drop it. Okay, that's surprising. You would expect that the book would fall faster, allowing the paper to just float away, right? But it didn't happen. We'll try it again, maybe in a different orientation, from a different height. Still the same result. The book and the paper always fall together, right? This is interesting. Let's ask a few questions about it. Why did the paper actually float and fall, and the book as it is in the first scenario? And what really happened in this situation where the paper is on top of the book? If you have seen this experiment before, you would say the answer is buoyancy. And you're right. Buoyancy is just the force that the air is applying from the bottom when an object is falling, right? So when any object falls from a height, of course, it's due to gravity and it falls down. But then if the object is heavier than air, then you don't really feel the effect of buoyancy. So there is air in this column, which is actually pushing the book upwards. Now, when it comes to paper, paper is actually lighter, it's less denser, so you can actually see the effect of buoyancy when it falls. In the case where the paper is on top of the book, why people would expect that the paper actually leaves the book when the book falls and the paper starts floating is because we've all seen the moment of inertia, right? So when you're in a moving car or a bus and it suddenly brakes, you tend to move forward. This is because the part of your body which is in contact with the vehicle stops abruptly with the vehicle, but the upper portion of your body is still in motion. This is moment of inertia. And now here people would assume that since paper and the book are both in contact, when you let it go, the book experiences a higher gravitational force. And that's the assumption that people make. So book experiences a high gravitational force and it falls quickly, leaving the paper behind, and paper still follows the same exact path. But now that we know what buoyancy is, we can argue that the book is actually clearing the air below it, allowing the paper to fall along with it. If you've seen videos where they experiment with a feather and a metal ball in a vacuum chamber. So a vacuum chamber is a box where the air is vacuumed out. So there's no air in it, so there's no buoyancy. In that scenario, the gravity is still acting. So when you drop a feather and a metal ball together from the same height, both fall at the same time. And this is exactly what is happening here without creating the vacuum. The vacuum is actually created by the book for the paper. This simple experiment has taught us what buoyancy is and how to think about gravity and moment of inertia as well. Now, if you're a teacher who wants to teach such a topic in class, these are the kind of experiments you can actually do, which are available at home or in school. Like it's just a book and a piece of paper available in every school. So you can use the things around you to teach kids science topics, and this is one way to do it. If you want to watch more such videos on simple science experiments that you can do in your classroom and help children learn hands-on with everyday items, things that you can find in your classroom, then please stay tuned for more such videos on this channel. Hey guys, sorry for the abrupt ending, But please like, share, and subscribe for more such science videos coming your way. Thank you so much.